Hello wonderful person, this is Anton, and it's about time we'll discuss some of the updates about the Voyager program, and specifically Voyager 1, sometimes also referred to as the most distant human creation in the entire universe. And that's because, as we speak, this 49-year-old probe is currently over 25 billion kilometers away from us, and is continuously traveling farther and farther. As a matter of fact, this year, sometimes in November of 2026, there's going to be a major achievement, or technically a kind of a major symbolic milestone. At this point, Voyager 1 is projected to reach a distance of exactly 1 light day. 1 light day away from the planet, basically meaning that the communication in this case is going to take at least 2 days, because the signals have to travel to the probe and then back from the probe. And this is of course going to be the first time in history that a human-made object is so far away that the light itself takes 24 hours to reach the spaceship. In more scientific terms, this is going to be approximately 173 astronomical units away from the planet. But one of the main reasons I wanted to discuss Voyager 1 is because very recently we actually did have some updates about the mission, and NASA engineers once again had to do something quite extraordinary to essentially allow this probe to function for a few more years. And so here they basically performed a kind of a deep space surgery in order to prevent this probe from failing completely. And the thing is, in the last 2 years, since the last update, this particular probe has experienced a few cases when it basically almost failed, and when scientists almost completely lost communication with the entire mission. And so here we had at least a couple of computer failures, power shortages, and even the event that's now known as the Great Memory Crisis of 2023. Yet despite all of this, using some of the most impressive engineering hacks in history, NASA engineers made sure that it still works and is still communicating with us even right now. And so let's discuss some of these new updates and talk about some of these recent announcements, but I guess first, just for the context, why exactly do these probes matter, and why do NASA engineers care about them so much? Well, first, to understand this, we have to clarify where Voyager 1 and Voyager 2 are currently located. Now, based on a lot of press releases, most people assume that both of these probes have actually left the solar system and are now traveling in the interstellar space. But that's actually not entirely correct, because in this case everything depends on the exact definition of the solar system. And to be more exact, both of the probes have left the heliosphere, the protective bubble of particles and various magnetic fields created by the sun, but technically they're still inside the solar system and have not even reached the Oort cloud. But the heliosphere border was officially crossed in 2012 by Voyager 1 and 2018 by Voyager 2. And so essentially they're traveling through the region where we normally find a lot of massive icy objects, but not the same objects that usually create comets. Comets usually come from the Oort cloud, and it will take Voyager 1 and Voyager 2 another 300 years to reach this region. And they will officially leave the solar system in approximately 30,000 years. And so they're going to stay in the solar system for quite some time. But nevertheless, these are very important probes for one simple reason. Voyagers are the only spacecraft currently providing direct measurements of the interstellar medium beyond heliosphere. And specifically, even right now, they're measuring the density of space, the temperature of interstellar plasma, and can even count cosmic rays that never really get inside the solar system and never reach planet Earth. Mostly because the sun's bubble, heliosphere, blocks them. And so once both of these probes go silent, we're actually going to lose our only opportunity to study real space outside of our home. But because of these probes, in just the last few years, scientists have already learned so much about the heliosphere, with many discoveries basically rewriting our current understanding and helping us learn just a little bit more about what happens beyond the sun. As a matter of fact, in one of the previous videos, we've discussed how this image of the heliosphere is not actually entirely correct. It does not seem to form this perfect cometary shape, and instead was surprisingly discovered to have a more croissant-like shape that you see right here, with a lot of these discoveries basically being made because of the Voyager mission. But as I mentioned, the last 2 or 3 years have actually been just a little bit stressful and involved some dramatic events. And the most dramatic event started on November 14th, 2023. This is when Voyager 1 suddenly stopped sending usable data and instead began transmitting unusual zeros and ones, basically gibberish. And this is when a lot of scientists thought that maybe this was the end of the mission. But NASA's Jet Propulsion Laboratory spent months investigating and eventually traced the problem to a single malfunctioning chip in the flight data subsystem, the computer responsible for packaging scientific data before it's sent to Earth. And so here this particular chip simply worn out because it was constantly hit by high energy particles. But to fix this actually involved something super complex. The engineers couldn't just replace the hardware, so they actually had to relocate the code stored on that broken chip to other parts of the computer memory inside Voyager 1. But the problem here is that the total memory is only 68 kilobytes. That's like basically the size of a tiny JPEG picture on your phone. And there was no single spot large enough to hold the code. So they actually had to slice it into sections and then restitch it across different parts of the remaining healthy memory. And by June 2024, the software relocation worked, and the Voyager 1 once again began sending back scientific data. So whatever magic they managed to do here, it actually sounds absolutely mind-blowing. But within just a few months after this, there was another problem. On October 2024, NASA actually sent a command to turn on one of the Voyager's heaters. And this somewhat normal request unfortunately triggered the spacecraft's fault protection system, because in this case the probe is running on a depleted energy source with its nuclear power battery barely functioning. And so here the automated system thought it was draining too much energy and automatically shut off the main X-band radio transmitter, preventing further communication, with Voyager 1 missing its scheduled calls and basically becoming inaudible. And so it actually took some time to realize that the probe was now communicating on a slightly different band. Specifically, it was using the S-band transmitter in order to save power. But the S-band is much weaker and actually has not communicated with Earth since 1981. It was basically only used in the inner solar system. And so at the current distance, the signal was just super faint. But thankfully, the Deep Space Network in Australia, specifically in Canberra, was able to hear this old frequency, and the engineers managed to switch on the older system by November of 2024. Which once again sounds super complex and kind of mind-blowing, but that's just to show you how ridiculously smart some of those engineers are. And well, for the past couple of years, we haven't really heard much until now, April of 2026. And that's because unfortunately Voyager has now reached its next milestone. The power in this case is so low that NASA has to shut down another one of its instruments. In this case, they finally shut down the Low Energy Charged Particle instrument, responsible for measuring ions, electrons, and cosmic rays. And this instrument ran for almost 49 years and allowed scientists to analyze solar wind and planetary magnetospheres as the probe traveled across the solar system. But it's now officially off, which means that Voyager 1 is really only operating 2 instruments now and is going to be sending a lot less data. The only active instruments are the magnetometer and the plasma wave subsystem. As the name implies, the magnetometer measures the magnetic fields, and the plasma wave subsystem is crucial for studying the plasma waves in the interstellar space. But in the next few months, NASA is going to be doing something else that risks potentially shutting down the probe completely. Here, they are preparing for what's called a Big Bang maneuver, or basically a kind of a swap where a lot of the currently running devices are going to be switched for the lower power alternatives in order to keep the spacecraft's heaters running. And that's because if they don't do this, or if they don't switch to the low power devices, the Voyager's fuel lines are most likely going to freeze, which could be the end of this mission because it just does not have enough power left. And so despite all of these clever hacks and all of these solutions over the years, the end for this probe is definitely approaching. As a matter of fact, every single year it seems to lose approximately 4 watts of power because its nuclear battery is slowly being depleted, with most experts believing that by 2027 or 2028, the probe will no longer be able to power even a single scientific instrument. It's still going to be able to communicate, but it's just going to have nothing to say to us. And because it's moving away farther and farther, by 2036, it's going to be far enough from the Deep Space Network that none of the current telescopes will even be able to hear it. Which means that it's going to travel by itself, unable to hear us, and unable to communicate. Although, in contrast, Voyager 2 seems to be doing a lot better. Even though it's just a little bit closer to us, at 140 astronomical units, right now it still has 4 scientific instruments operating and reporting back to us, and unlike its partner, it seems to have just a little bit more energy, and seems to have just a few less problems. But eventually, both of these probes will fall silent. Their batteries will become depleted, and we'll no longer be able to hear them or communicate with them. And so both of these probes are going to be continuously drifting through outer space, with Voyager 1 possibly coming really close to the star known as Gliese 445 in approximately 40,000 years. But because of the constant interaction with the cosmic rays, and possibly even collisions with various micrometeorites, at this point both probes might be completely shredded apart and just resemble some kind of a metal scrap flying through space. Nevertheless, it's still really impressive that even after almost 50 years, both probes are still operating, still working, and still sending back data. In contrast, my phone from just 5 years ago barely functions. But we'll definitely come back and discuss this mission in a little bit more detail in some of the future videos, because at this point I think everyone's just really excited to see how far we can push this and how much data we can collect from this mission despite its age. And so until future updates from NASA, thank you for watching, check out previous videos in the description, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.